All right, here we are with equilibrium. You're going to spend a lot of time working with equilibrium in general chemistry too, and so it's important to be able to write equilibrium expressions. Now, in terms of equilibrium expressions, when it says to write the expression, it really means the quotient. But remember, the quotient, there's a special case of the quotient when the reaction is at equilibrium, and we call that quotient the equilibrium expression. And so they really are the same thing. They don't differ from each other unless the reaction is not at equilibrium. Now, in general, what we say is that pure solids and pure liquids don't get included in the equilibrium expression because their relative concentrations are 1 and they would just cancel out. There's some more vigorous discussion of that you might have in a sophomore level class, but for general chemistry 2, we won't include solids and liquids. Now, everything here are gases. Now, it wants you to do it in terms of molar concentrations, not partial pressures, but the expression would be very similar. In general, an equilibrium expression is the concentration of the products divided by the concentration of the reactants raised to their stoichiometric coefficients. So I say something like this. I say products divided by reactants raised to their stoichiometric coefficients. And that's all we need to do in terms of molar concentrations. We're going to say that it's going to be for the products, the concentration of POCl3 times raised to the power of its stoichiometric coefficient, which is 2. Now we'll do the reactants, O2 times PCl3 raised to the power of 2. And that's all that we're trying to get you to do there. That's the equilibrium constant. Okay, so the next one would be O2 times SO2 to the power of 2 divided by SO3 to the power of 3. And the last one, a little bit more complicated, one more species to deal with. Water is a gas in this case, so it is included. It's going to be raised to the 8th power. NO2 is a gas. It's going to be included. It's going to be raised to the 2nd power. Hydrogen peroxide raised to the 6th power time. And then the last thing in the denominator is N2H4, and it's raised to the 1st power. These are the 3 equilibrium expressions the problem was asking you to come up with.